Final module of the week, 1.4, 1-4, investment returns and risk. This is going to be like rolling off a log. We're going to discuss in this module average returns, which we're going to measure with either the arithmetic average or the geometric mean. We're also going to talk about the variation, which we'll measure with the standard deviation or the variation. And the other measure we're going to talk about is the correlation coefficient, and that is a measure of how two series move in relationship to one another. So we're going to discuss all of those three things, first focusing on the arithmetic average and geometric mean. Here is the definition of the arithmetic average. R sub A is the arithmetic average or arithmetic mean. It's the sum of all the periodic returns divided by n. So it's the arithmetic average. It's the one when you've calculated in statistics, and it is the most common mean that you will see reported. Straightforward calculation. Here is the definition of the geometric mean. R sub g. What you do is take the product of 1 plus the periodic returns, take raise that to 1 over n minus 1, and it's a geometric mean. It has a very nice interpretation. If you take $1 invested at the beginning of the period and hold it to the end, reinvesting any dividends that you have invested, R sub 1, remember, includes both dividends and capital gains, so we're explicitly making the assumption here that dividends are reinvested. It shows how much will be available at the end of the period. I'm hopefully going to give a little bit of intuition mathematically to that in the next slide. I'm going to give some intuition behind this. Equation 1 here gives the definition of the geometric mean, so that comes from the previous slide. Equation 2 shows the same thing as equation 1. We're just taking the 1 over to the other side, so just rearrange the formula a little bit. And then equation 3 multiplies through or takes the n over to the other side. So here is the expression in equation 3, same as equation 1. Now look at that equation. This is the definition of the future value, or if you will, or the value of money currently invested now, 1, with each period, 1 plus R1, or 1 plus R2, with that return each period. The geometric mean on the left-hand side of the equation just finds the factor that equates all of that. So that is the intuition behind the geometric mean. Alright, let's give an example of the mean and geometric mean in this sheet. Go to the mean geometric sheet in the Excel worksheet that I handed out. I'm going to show returns for 3 years for 4 assets. Asset A, Asset B, Asset C, Asset D. Asset A has a 5% return in year 1, year 2, and year 3. So its mean, or its average, would be 5%. Asset B has a little bit of difference, 0.03%, 3% in year 1, 7% year 2, 5% year 3, still 5% return. 5% return on asset C and 5% return on asset D. So all of these have the same arithmetic average. Minus 1 is the first year return, so we had a negative return. 2 and 5. Minus 4, or minus 40%. Big downturn. Still a 5%. Had a big upturn in the next year. In calculating the geometric mean in Excel, it's done over here, and here you got a trick there is a function to calculate geomean in Excel, but you have to trick it a bit. I'm just giving you an example here. What I do is take the return, add 1 to it. Reason why I do that is the function Excel will not work if there's a negative return in it, or negative number. So if you tried to calculate the geomeans just here directly, it would blow up. Let me just show you. Negative numbers don't work. Gives you the number. Alright, so we have these. Come over here, calculate the geomean, and subtract 1. Let me put these geomeans here, over here, so we can do a comparison. Asset A has the same arithmetic and geomean. Asset B about the same, or it's the same. Asset D or C, arithmetic average but lower geomean. Asset D actually has a negative geomean. What we know about geometric means is that when there are negative returns, they will differ from the arithmetic average. Geomeans will always be below the arithmetic average, and the more pronounced the spikes below 1 are, the more the geomean will be below the arithmetic mean. So this had a bigger spike, so our arithmetic average was below that, or more further below it. Here's the intuition. Remember what the geomean does. It calculates, if you invest $1 at the beginning of the period, how much you will have at the end of the period, given that you reinvest the returns in the asset. Let's show that. And here we've done this. This is 1 plus the asset. So we can do those calculations if we invest $1 in year 0 right over here really easily. If I invest $1 in year 0, I will have $1.05 at the end of year 1. If I invest in asset A, if I invest in asset A, I'll start at 1.05 at the beginning of year 1. I'll have a 5% return, get 1.10, and at the end of the year I'll have 1.15. Let's come over here and look at asset D. If I invest $1 and have a minus 40% return, I will have $0.6 at the end of year 1. I have a 45% return in year 2, but I started out with 60 cents, and 45% return on 60 cents only gets me to $0.87. Another 10 cents, 10% return, I get to $0.957. So my $1 is $0.957. That follows it through. I could do the same thing. Remember my reworking of the equation here. I can take 1 plus my geometric mean, raise it to the 3 power in this case because we have 3 periods. Oops. Got to put a parenthesis around that. 1.15. Exactly the same. So this is my yearly average return, given that I invest $1 at the beginning of the period. In a lot of respects, the geometric mean is preferred over the arithmetic mean. It sometimes is difficult to calculate. Here's the definition of the standard deviation. Same standard deviation definition you've seen, mathematical formula. Higher standard deviations mean more variability, more risk, and that's generally not preferred by an investor. More risk, less preference, so we would like more stable returns. Investors prefer higher returns, higher arithmetic averages, higher geometric means are preferred, and lower risk, so lower standard deviations. Here is the definition of the correlation coefficient, the correlation between x and y, or two series, x and y. Again, we use this, and this is going to be a very important variable when we talk about diversification. In the red there, you see the interpretations. 1, if we have correlation coefficient, and correlation coefficients range from 1 to -1. 1 would be perfectly correlated, -1 would be perfectly uncorrelated. Here's how this works. If we have a correlation coefficient of 1, the two series may move in lockstep with one another up and down. -1, they move with lockstep with one another but in opposite directions. One goes up, the other one goes down, and vice versa. 0 means you cannot discern a pattern by what, if X does something, you don't know what Y does. From a diversification standpoint, you want the lowest correlation coefficient you can get. In fact, if you had a negative minus correlation, -1, or even a negative correlation, you can make an asset by combining the two assets such that you can have a safe investment. Obviously, negative correlations do not occur very often. Even with high positive correlations, though, you can come to the point where assets, as you increase the diversification or increase the number of assets, even with high correlations, you can lower risk. And that's one of the things that we'll talk about next week. Final example here, correlation coefficient. Here we have asset A, asset B. Here we have the mean calculation. This would be the arithmetic mean. 0.057. It's average and function in Excel. Average function of B. Over here we have the geometric mean calculations, just like we did before. Standard deviation is STDEV. Correlation is correlations, CORREL. Correlate this series with this series. Alright, looking at these assets. Asset B has a higher rate of return, but higher risk. Correlation coefficient is 0.29, so they're less than perfectly correlated. That completes our modules this week. We'll be talking more about mean and standard deviations next week. And as you're doing the homework, you will get to calculate mean, standard deviations, and correlation coefficients.